All right, we're going to start our first chapter, and before we get to limits, we're going to actually spend first lesson just reviewing some factoring and doing some different types of factoring that you probably haven't seen before. So we're going to start with looking at some perfect squares. That's these first two formulas. Then we're going to do difference of squares, and then our last one will be cubics, which are like either difference of cubes or sum of cubes. So we'll go through those one at a time so you kind of get the hang of how they work again. So we'll start with perfect squares, and remember with this type of equation that would be something where you had something like x squared plus 6x plus 9, and then we'd factor that into x plus 3 squared. Okay, so let's try a few of those. So they don't have to be perfect squares in terms of numbers. We can deal with roots, we can deal with different variables, and so on. So a good trick to do with these ones is to just square root the first and the last term and then see if the middle terms work out. So if we square root our first term, we get x. Square root our last term, we'd have 2y. And if we FOIL that out, so you'd have x squared, which is good. We'd have 2xy and another 2xy, which gives us the 4. But you can see in our question we have a negative. So that means we would have had to have x minus 2y instead. And then negative 2y times negative 2y is indeed the 4y squared. So that's it. So you could write it like that, or you could write it out twice, whichever you prefer. Let's try it again with the next one. So if we square root the first one, we get an x. And if we square root the last one, square root of a quarter is a half, so we'd have a half y. So this time let's write it out twice instead of once squared. So again, if we double check our FOILing out, x squared works. We have a half xy and another half xy, which is the 1 in the middle. And then a half times a half is a quarter, so that's good. So keep going, same sort of idea again with the next one, except you can see we get x again, and it's minus in the middle, so we should have a minus, and square root of 3 is just root 3. We don't need to have perfect numbers, it'll work fine with roots. And so our second term should be the same. And again, if we FOIL it out, the middle terms will have x times root 3 and another x times root 3, which would be 2 root 3x, so that is indeed correct. And our last one works the same again, except we would have root x plus 2. And we'll write this one out squared. And again, if we FOIL it out, the middle terms do indeed work. So perfect squares work pretty good. Just basically square root the front and back and make sure the middle works out. For difference of squares, same process again, except remember our middle terms should cancel. But we can still square root the front and back, so we'd have x minus y. And to cancel that middle term out, we just need x plus y. So you just got to do 1 plus 1 minus. So do the same thing with the next one. We'd have x plus 3, x minus 3. And if you really want, you can write these as x plus or minus 3. You can write them as one factor. That works as well. And the last one, or the next one, again, do the same thing. We'd have x plus root 3 and x minus root 3. And the last one, if we square root front and back, we get root x plus 4 and root x minus 4. Okay, so those are it for difference of squares. So those are both pretty easy. The next one we're going to look at is what we have, either a sum of cubes or a difference of cubes. We still only have two terms. We're not dealing with normal cubic where we'd use long division or anything like that. And we basically just follow these two formulas. So you just figure out what you're doing. So just like square rooting, we're going to cube root each, and that'll give us sort of our a and b value in the formula. So for this first one, cube root of x cubed would be x. Cube root of 27 would be 3. So that's our a and b values. So now we just plug each of those in. So we put our x in for a and put our 3 in for b. So the rest of it would be x squared. You can see the sign is opposite. We get negative. And then we'd have x times 3, or we'll write that as 3 times x, and then 3 squared would be 9. And again, if we FOIL that out, we will get indeed what we started with. The reason why we need that negative is to cancel out those middle terms. Okay, so let's do the same thing for the next one. Cube root both of them. So cube root of 8x cubed would be 2x. Cube root of y cubed would be y. And now we square each of those. So 2x squared would be 4x squared. our sign changes for that middle term, and then we have 2x times y, and our last one would be y squared. And that's it. So just follow the two formulas. You can see they work pretty straightforward. You just got to make sure you cube root everything, and then that'll be your a and b term, and then just plug those values in for a and b in either of the two formulas. The last type of factoring we'll look at is when we want a common factor, and we got some fractions and things like that involved. It looks quite strange, but you'll see you can always change these and simplify them down to where they could be factored. And basically the trick is we want to common factor out the x with the lowest exponent. So in this first case, a half is our lowest. So if we divide everything by x to the half, we just got to remember we have x to the 5/2 divided by x to the half. Using exponent rules, that would give us 5/2 minus 1/2, right? When we're dividing, we subtract exponents. So 5/2 minus 1/2 would be 4/2, which would simplify to just a 2. So we should get x squared. Same thing for the next one, divide that by x to the half. So 3/2 minus 1/2 would be 2/2, or just 1. And the last one, we divide by x to the half, that'd give us x to the 0, which is just 1. So we basically cancel all those out. And that's it. So once we take out our x to the half, you can see we get a regular kind of polynomial. So we can actually factor that using normal sum products. So we'd have x plus 2 and x plus 1. And that would be our final answer. So this next one, do the same thing, except in this case our negative 3/2 is our smallest exponent. So we want to divide by that. So we're going to have 1/2 minus negative 3/2, which again will be 4/2. So we should get the same type of thing. We'd have x squared out front, and then we got negative 1/2 minus 3/2, which would be 2/2, so that should be our 7x. And our last one will cancel out, so we just get 12. So often when you're doing these, you should get a regular polynomial inside the brackets. If you don't, chances are you probably did something wrong. So again, if we use our sum and products, we could get 4 and 3. So that's it. So that's just some quick factoring review. We'll do a little bit of practice on this, and then that'll help us deal with some harder limit kind of questions later on.